Good morning. Before we continue with 1.8, I would like us to do this warm-up problem. So I have a game up here, 2 truths and a lie. So you've probably played this as some like get to know you activity, but we're going to play it as a math warm-up activity, okay? So I have 3 graphs and 3 equations, and your job is to determine which ones are the truths and which one is a lie. So there's 2 truths and 1 lie. What I'd like you to do, instead of just sitting there in silence, turn to a neighbor and go ahead and have a conversation about these 3 and see if you and your neighbor can determine which one you think is the lie. Okay, I'll give you a few more seconds to finish your conversations. Okay, so let's start talking about these. I will start with our 2 truths. This one right here is a truth. We have the square root of x shifted right 2 and a vertical stretch of 2. So you can see the vertical stretch has been applied. These 2 coordinates have been doubled for their y value, and you can see we have that shift to the right 2. Our next truth is the 3rd one. Remember, if we have a shift and a stretch, or a shift and a reflection, or who knows, all 3 inside of our function, we do have to factor it out because they all affect each other. So when we factor out this 2, we're left with x minus 3. So this is really a shift 3, right 3, and a horizontal shrink of 1/2. So you can see we have that shift right 3, and then these x values have been cut in half from what they normally are. Okay, so normally this would be over 1 up 1, but it's over 1/2 up 1, and normally this one right here would be over 4 up 2, but it's over 2 up 2. This one is actually the lie. Okay, when we have a negative inside of our function, that is a y-axis reflection. So we need our square root to be shifted, to be reflected across the y-axis, and then shifted right 4. So this should actually look like this. That is not true. Okay. Just real quick before we get started with the rest of our 1.8 notes, if you are gone on Friday, you are handed a blank quiz, and that quiz needs to be done like a homework assignment. You only get 1 try at it. That is due on Wednesday. If you are here on Friday, you have the opportunity to get points back using the yellow sheet. you must redo the entire problem, whether it's all of A, all of B, all of C. If you missed points on that particular part, redo it all and explain what your mistake was. If you don't explain your mistake, you don't get the points back if your work is correct. Okay, those are due on Wednesday. Now, over the weekend, you had an assignment about the first part of 1.8, the adding, subtracting, multiplying, and dividing functions. Today, we're going to talk about the fifth way to combine functions, and that's the composition of functions. This is something that you did learn about in Algebra 2. Okay, so the composition of functions is when we put a function inside of another function. Okay, this notation right here I'm highlighting in yellow, that is probably what you're familiar with. Okay, what I'm highlighting here in pink, this is what I need you to be able to recognize means the same thing. This little circle right here, this open circle, that is our composition symbol. So F, little circle G, that just means F of G, or F composed with G. Okay, and this notation that I just underlined is what you're going to be the most familiar with. So if you see that pink notation, it is fine, and that's probably what I'll do, to rewrite it as the yellow notation. Okay, now I know that this is something that you did in Algebra 2, and we're going to work on it again, but we're going to add a little bit to it. Remember, this first semester of pre-calculus, you're seeing a lot of review, right? But then we do a little bit more with it compared to what you did in Algebra 2. So what we get to add to our composition is the domain. Okay, and you're going to write down this domain, and it's probably not going to make sense yet. And then I'm going to have you draw this picture, and we're going to talk about this picture, but understand that it might not really make sense until we do an example or two together. Okay, so the domain of our composition is the set of all x in the domain of G, such that G of x is in the domain of F. Okay, write it down and draw this picture, and then we're going to talk through this picture together before we do our examples. Okay, so when we think about the domain, just like when we actually perform the composition, we want to think of the inside out. So up here, when we actually do a composition, we are going to take function G, and we're going to put that in to our function F. All right. So when we talk about the domain, we have the set of x's that we are able to plug in to our function G. So the first thing we need to think about is the domain of G of x. Okay. Then what happens? These outputs then get thrown into function F. Okay. So now we need to think about, what does this equation look like? So we need to think about, what is the domain of our outcome? Okay. And it's where these two overlap that we actually have our domain for the composition. Okay. Basically, we need to think about, are there going to be any restrictions for the domain of G? Because those will affect our final domain for our composition. All right, what do I mean by that? Let's go ahead and do an example so I can show you. Go ahead and write down these two. And while you're writing them down, and this is where 1.7 is going to come in handy, while you're writing these down, I want you to also think about their domain. You shouldn't need to graph these to think about their domain, but if you think about the parent functions and transformations, in your head you should be able to visualize the graph and be able to determine what the domains are by thinking about those graphs. So write these down and think about their graphs so that we can determine the domains. Okay, so when we first think about f of x, x squared minus 4 has a domain of all real numbers. It is a parabola, it's a parabola shifted down 4, and so we don't have to worry about the domain. A parabola always has a domain of all real numbers. Now, when we think about g of x, we have a square root shifted to the right 3, which means its domain is going to be 3 to infinity. Our graph looks like this, and this is what you're thinking about visually in your head. Okay, so our domain is 3 to infinity. Okay, now, since these two domains overlap, they have x's in common, then we can combine functions. We are okay to go ahead and do the composition. So f composed with g of x. Okay, so the first thing we're going to do is we're going to take g of x and let's rewrite it. So we have f of g of x. Oh, that's not right. There we go. How's that? So now, just like we would, okay, just let's say for a second, I'll go to a different color here. If I asked you for f of 2, you would take 2 and plug it in anywhere there is an x, right? Here's an x, and so I replaced it with 2, okay? Now, we're going to do that same thing, but now we just have a function, okay? So here is what we're plugging in, and here is our x. So I'm just replacing x with our function g. Our function f was x squared minus 4. So here is my x squared minus 4. Okay, well now, what happens? The square root and the square cancel, and we're left with x minus 3 minus 4. So x minus 7 is our reduced outcome. Okay, now if we were going to talk about the domain of just y equals x minus 7, we know that that is a linear function, and so its domain would be all real numbers. But this really isn't just y equals x minus 7. This is a composition. This is f composed with g of x. And it's important to remember that when we actually go through compositions, we plug inside first. And so the domain of the inside is also going to affect the domain of this outcome right here. All right? So we need to compare the domain of g, our inside function, with the domain of our outcome, and we need to see where those overlap. Okay, so since the overlap is 3 to infinity, then the domain of our composition is 3 to infinity. We'll go through this one together. What I want you to do is write down these two and determine what their domains would be. Okay, so 1 over x, we cannot divide by 0, so this would have a domain of everything except 0. G of x, 1 over 2x. Once again, we cannot divide by 0, so this is going to have a domain of everything except 0. Okay, so let's once again do f composed with g of x. Just get used to that notation, okay? And it is okay if you want to go ahead and change it to f of g of x. Okay, so first we'll start with our inside function. Remember, its domain is going to be important. Okay. All right, so we have f of 1 over 2x, which means we are taking 1 over 2x and we're plugging it in anywhere that there is an x for our function f. So f is 1 over x, so this is going to become 1 over 2x. Now, when we talk about dividing, we know that dividing is the same thing as multiplying by the reciprocal. So we have 1 divided by 1 over 2x. So we have numerator times the reciprocal of the denominator. I think one of the middle school math teachers likes to teach that as copy dot flip. That's how you learned it. That's what we're talking about here. So we end up with 2x. Now, y equals 2x would have a domain of all real numbers. But this isn't just y equals 2x. Oh, shoot. There we go. This is the composition. And since the inside function had a domain of everything but 0, we need to see how that compares to this domain here. Okay, since the inside was restricted to everything but 0, then our composition domain will also have to be restricted. If we can't plug 0 in for G, then we can't plug it in for the composition as a whole. Okay, so you have a couple things to do for me. Number 1, you have 2 days to redo your quizzes. Number 2, you have 1.8 bookwork for this evening. It shouldn't take you very long, so maybe you can even get it done in class. And then number 3, there is a 1.9 preview assignment. Tomorrow we're going to talk about inverse functions, and it'll really help the conversation if you can just see what you remember from last year. So do what you can on that 1.9 preview assignment. I know there's a challenge at the end. It's okay if you don't get the challenge. It's called a challenge for a reason, but I want you to try. But at least come up with what you remember graphically, numerically, and algebraically about inverses, and that'll help us tomorrow when we have our conversation. And then we can really get into more of the pre-calc type examples, because we will have more time to do those as opposed to trying to remember everything